So this video is going to be on equation word problems. So typically when it comes to equation, you are usually given an expression or equation such as like 2x plus 4 is equal to 3x minus 7. Now we would consider this an equation with variables on both sides of the equal sign. So here's a variable and here's a variable. When it comes to equation word problems, those are typically the word problems that you're going to get. So you're usually going to be presented with either a paragraph and you are going to be required to create an equation out of it, or you're going to be given an equation and they're going to tell you to pick a certain paragraph that fits that equation. So we have to understand what it is that we're setting up. So when it comes to equation word problems, these are typically going to be the equations that you're going to need to set up. It's usually going to be a term plus or minus a term is equal to a term plus or minus a term. And those terms are usually going to be a variable and a number is equal to a variable and a number, which is this right here. So variable, a number, variable, a number, or a constant. So in the equation word problems, you're going to have to look through the paragraph, and you're going to have to see, okay, which one has a variable, which one has a number, which one has a variable, which one has a number. So there's going to be certain scenarios. So it's going to be scenario such as scenario 1, scenario 2, or they're going to say person, like a person, the first person, person number 2. So it's going to be comparing two different people or having two different scenarios. And usually what you're going to have to do is you're going to have to make them equal to each other. So usually the question is going to be like, at what point is scenario 1 and scenario 2 have the same amount? So same amount, meaning that you're going to make them equal to each other and then solve for the variable, solve for x. So here's what we mean. So let's go ahead and write in our keywords for variables, which are per, every, and each. So whenever you see these words next to, so in your paragraph when you're reading, whenever you see the words per, every, and each, those are typically going to be your variable words, meaning that it's going to be the number that you set up as a coefficient, number being the coefficient next to your variable. So let's take a look at this. Let's read the example that they give us, and let's see if we can find scenario number 1, scenario number 2, and a variable for each one and a number for each one. So this one says container A, so we're already given our first scenario, and container B, and we're already given our second scenario. So on paper, I'm going to go ahead and I'm going to write up here container A and container B. I already know I'm going to be comparing two different containers. So these are our scenarios. And they have leaks. Container A has 800 milliliters of water. So I'm going to go ahead and write that in, 800 milliliters of water. So when it comes to these two, I forgot to mention, so constants, so the numbers, so the variables are going, so in the verbiage, they're going to have per, every, and each for your variables. And for your constants, they're typically going to be starting amounts. So when it comes to numbers or constants, you're going to look for words such as currently has, initially, starting. It's your starting amount. So whatever your starting amount is, a number that's fixed, that doesn't change, that's going to be your constant, your number. So in this case, container A has, so keyword has, it currently has 800 milliliters of water. So we're going to express 800 exactly like it is. So I'm going to go ahead and write that in, 800. Right now I'm just writing down facts. I'm not setting up any equations yet. Okay, and is leaking 6 milliliters per minute. Here's our variable word. So 6 milliliters per minute. So that means, I'm gonna write that in, 6 milliliters per minute, our keyword per, our variable word. So that means I'm gonna set that up as 6x, where x equals milliliters per minute, or excuse me, x equals minutes, because per minute, so x equals minutes, so per minutes. All right, so setting that up, we have to be careful too. So if we're starting with 800, so we're going to set that up as 800. We have 800 milliliters, but I'm not going to put the units because now I'm setting up the equation, and it's leaking at 6 milliliters per minute. So if it's leaking, so you have to be careful what verbiage it gives you and what exactly is happening in the scenario. So if it's leaking, that means that it's going to be losing water. So I'm going to put minus 6x, 6 ml per minute. All right, so now I have container A. Now I'm going to set up container B. Container B has 1,000 milliliters and is also leaking at 10 milliliters per minute. So here's our per. So I'm going to go ahead and just come down here and set it up. So it has, what was it, 1,000, right? Yeah, so I had 1,000 on container B. So 1,000, and it's leaking at 10 per minute. And then it's asking us how many minutes M. So really, I guess I should have put M equals minutes, but no worries. Doesn't matter what variable you use, just as long as you set it up. I'm going to go ahead and rewrite it with M. So 800 minus 6M, and then 1,000 minus 10M. So all I did was just change the variable to the variable that they gave us. So how many minutes M will it take for the two containers to have the same amount? So there's our keyword, the same amount of which inequality we're going to use. So if we want to know when they're going to have the same amount, at what time they're going to have the same amount, we're going to make that equal to each other. So all you do is set up the equation, the variable, and the constant equal to, and then to the scenario number 2, variable and constant. Remember, it's okay if you switch your terms out of order, just as long as they're on the same side of the equation. So they can be out of order. So basically what you're going to do now, let's see if we did it down here. So 800 minus 6m is equal to 1,000 minus 10m. So that's how you'll set those up. Let's go ahead and solve for it. So we have variables on both sides and constant on both sides. So I'm going to go ahead and do plus 6m plus 6m. And then I'm going to want to move this one over here. Since we're canceling the variable over here, we're going to have to cancel the constant over here. Minus 1,000 minus 1,000. That will cancel out. That will cancel out. 800 minus 1,000 should get you negative 200 is equal to negative 10 plus 6, which is going to be negative 4m. So we have negative 4 times m, so divided by negative 4, get it equal to 1. So m is going to be equal to 200, negative 200 divided by negative 4. It's going to be 50, so 50m. So in 50 minutes is when they'll have the same amount of water in their tanks. So let's take a look at these word practice problems. It says at one store, a trophy costs $12.50. Engraving costs 40 cents per letter. At another store, so I'm going to go ahead and set up store number 1 and store 2. So at one store, a trophy costs $12.50. So that's the fixed amount. Engraving costs 0.40 per letter. So I'm going to put plus 0.40x. At another store, the same trophy costs $14.75. So that's our fixed amount. Engraving costs 25 cents plus 0.25x. How many letters must be engraved for the cost to be the same? There it is again, the same. So we're making it equal to each other. Notice a pattern. We have our constant variable is equal to our constant variable. All right, so I'm just going to set these up. You should know how to solve them. So I'm just going to set them up so that way you know how to set them up at least. All right, so Jake weighs 120 pounds. So let's go ahead and write in Jake. He weighs 120 pounds and is gaining 10 pounds each month. There's our variable word, each month. So I'm going to put plus 10 M for months. Dylan weighs 150 pounds. So Dylan weighs 150. What's the starting amount? So remember, constant, the number by itself is going to be like the starting amount. So Dylan weighs 150 pounds and is gaining, also gaining. So that's going to be plus 4 pounds each month. Another variable word. How many months will it take for Jake to weigh the same as Dylan? So that means we would make those two expressions equal to each other, and then you would solve for M by solving equations with variables on both sides. All right, a 12-inch candle and an 18-inch candle are lit at 6 p.m. The 12-inch candle burns. So we have a 12-inch candle. So I'm guessing, I guess I could have put candle number 1, but 12 inches is what it's starting at. Burns a half inch. So burn, so if it's burning, we're going to subtract. So minus 1/2, or you can put 0.5 inch every, there's our variable word, every hour. So I'm going to put x, where x equals hours. Whoops. Fix the camera there. Okay. The 18-inch candle burns 2 inches. So we have an 18-inch candle. It burns 2 inches every hour. So 2 inches every hour. So minus 2x. At what time will the two candles have the same height? So equals. So it'll be 12 minus a half x is equal to 18 minus 2x. Again, variable constant is equal to variable constant. All right, so in this last one says, make up your own word problem for the following equation. So it has 50 plus 30x equals 80 plus 20x. So this could be anything. It could be, you could put it into money, you can do a scenario up here, it can be any scenario. I'm gonna say, I'm just gonna give it, I guess I'll use money. So I would just say at store 1 and store 2. So I guess I would say at store 1, or let's just do like a gym membership. That maybe makes sense. Like we're gonna get a gym membership. So gym 1, gym 2. Okay, so at gym 1, let's say you have to pay $50 down. So we'll say at gym 1 you have to pay $50 down and then $30 per month. So $50 down. It's another good example too, like initial fee, like a registration fee, or like a one-time fee that's usually as a constant too. So we'll say $50 down and $30 per month. And at gym 2, it's $80 down and $20 per month. So our keywords, variable words, per and per. So that can be, and then the question could be, at what point, if you were paying for two gyms, then at what point would you be paying the same? How long will it take? Make sure you pay attention to your variable. So it depends on the variable. So X stands for months. So our question would have to be how long. So if it's, since it's time, it'd be how long would it be until you pay the same amount for each gym? So something like that. And that's word problem practice.